this is Anirudh, and in today's video we'll be doing 3 sums using a hack of the Kirchhoff's law as a part of current electricity. Please do follow us on our Facebook, Instagram and Telegram channels for your daily dose of math and physics. Let's get started with our JEE problems. In the last video we did a few sums with batteries and resistances, but when you have a combination of many batteries and resistances, you need to use Kirchhoff's law. Now generally Kirchhoff's law involves a lot of big equations and calculations that you need to solve, which you do not have time for in competitives. So today I'll be showing a little trick which will allow you to solve complicated circuits in a much quicker and simpler way. So suppose you have a circuit given like this and they ask you to find the current through each of these 3 resistances, all of which are 2 ohms each. The way you proceed with this is that you pick a common point and that assume that the voltage there, the potential there is 0 volts. So if this point is at 0 volts, this is also at 0 volts, and this point is also at 0 volts. There's a cell of EMF 2 volts attached to it. So if the positive terminal of that is at 2 volts, then the negative terminal has to be at minus 2 volts in order to maintain a potential difference. For the second cell, if the negative electrode is at 0 volt, then the positive electrode has to be at 12 volts. So the top end is at 12 volts. For this cell over here, if the positive end is at 12 volt, to maintain a potential difference of 6 volts, the negative terminal should also be at 6 volts, so that there's a potential difference of 6 volts maintained. Over here, for this 4 volt cell, the negative terminal is at 12 volts, so the positive terminal should be an extra 4 volt, that is this point should be at 16 volts. Now once you have figured out, okay, one more, if there's another cell over here, the negative terminal is at 0 volts, so the positive terminal should be at 2 volts. Remember, a cell only gives the potential difference, you just put the potentials at the electrodes accordingly. Now the problem reduces to very simple things. Suppose the current in this direction is I1, it goes from a higher to a lower potential. The current across this resistance over here is I2, it moves in this direction from 6 potential to 2, so I2 is the same over here. I3 would be moving in this direction, and let's assume that I4 also moves outwards in this direction. So if you want to find I1, you have a potential difference of 12 minus of minus 2, so 14 volts across a resistance of 2 ohms. So I can use the direct Ohm's law formula, that is V by R, that is for I1 case, that is 12 minus of minus 2 divided by the resistance 2, that is 14 by 2, that is 7 amperes. For I2 across this resistance, the potential difference is 6 volts minus 2 volts divided by the resistance 2 ohms, that is 4 by 2, that is 2 amperes. For I3, we only look at the resistance, the potential difference is 16 volts minus 0 volts, so 16 minus 0 divided by the resistance 2 ohm, that is 16 by 2, that is 8 amperes. Now if we use Kirchhoff's first law junction law here, we know that I1 plus I2 plus I3 plus I4 is equal to 0 by Kirchhoff's first law. So I4 is just minus of I1 plus I2 plus I3. If you put all the values, you will get it as minus 7 plus 2 plus 8 amperes, that is minus of 17 amperes. The negative sign here demonstrates that I4 actually flows in the opposite direction to which I have taken it as. So we just got the 4 values of the current, I1, I2, I3 and I4. Let's move to the next question where we solve a similar sum again. This is a similar arrangement with the different combinations of cells and resistances. So we proceed in a similar way with this. We pick this point to be at 0 volts. So these are also at 0 volts because there are no circuit components between them. If the positive terminal is at 0 volts, to maintain a potential difference of 8 volts, this terminal needs to be at minus 8 volts. If this is at 0 volts across a 10 volt potential difference, this end has to be 10 volts. And if the positive end of the 4 volt cell is at 10 volts, the negative end has to be at 6 volts in order to maintain a potential difference of 4 volts. So now I'll consider my directions of currents. This would be my I1 moving from a higher potential to lower. I have my I2. I can take this side as I2. In this direction would be my I3. And I'll again assume that the I4 moves in this direction. You may not be sure which direction it moves. Just put all directions outwards, and then at the end you will get the corresponding results. So like with the previous sum, we find I1 is equal to this. That is a potential difference 10 minus of minus 8 volts divided by the resistance 2 ohms. That is 18 by 2. That is 9 amperes. The second current I2, again I only look across a resistance, not across a cell. The potential difference across it is 6 volts to 0 volts. So 6 minus 0 divided by the resistance 2. That is 6 by 2, that is 3 amperes. And across I3, we have 10 volts to 0 volts. So you have 10 minus 0 divided by 2, that's 10 by 2, that is 5 amperes. Again, applying Kirchhoff's first law at this junction, I have I1 plus I2 plus I3 plus I4 is equal to 0. So I4 is equal to negative of I1 plus I2 plus I3. I put the values in. 9 plus 3 plus 5 amperes. Therefore I4 is equal to minus 17 ampere. Once again, since I got a negative sign, that just means that I4, instead of coming down, actually flows in the reverse direction. So those are my 4 values of current for this circuit. Let's move on to the next sum. This sum may look simpler, but it has to be approached a little differently. Let's see why. Like with the previous sums, I again assume this to be at 0 volts. So this is at 0 volts and this is at 0 volts. If the positive terminal is at 0 volts, the negative terminal in this case has to be at minus 2 volts. If the negative terminal is at 0 volts, the positive terminal at this point has to be at 4 volts. If the negative is at 0, this has to be at 6 volts. But you see, I still cannot find the current through the resistances because I do not know the potentials at the top points. So for this sum, what we need to do is we need to assume that the potential of this point is x volts. So if this is at x volt, this is also at x volt, this is also at x volts. Now with the potentials, I'll put the values of current. This is I1, this is I2, and this would be my I3. So let's find I1, I2, I3. Remember, this is the same I1 coming here. This is the same I3 coming here. So I1 is equal to x minus of minus 2 divided by the resistance 2. I2 is equal to x minus 4 divided by the resistance 2. And I3 is equal to x minus 6 divided by the resistance 2. Now I apply Kirchhoff's first law at this junction again, and I know I1 plus I2 plus I3 should be equal to 0. Put these values in. X of minus 2 means x plus 2 divided by 2 plus x minus 4 divided by 2 plus x minus 6 divided by 2. They all add up to give me 0. So I can find x from here. X is equal to, you can take divided by 2 common and multiply it off with 0. So you have x plus 2 plus x minus 4 plus x minus 6 is equal to 0, or 3x minus 8 is equal to 0, so 3x is equal to 8, or x is equal to 8 by 3. This is my potential we got at this point. Once I have the potential, then I can go back to the way we proceeded in the previous sums. I can get I1, which we have as x plus 2 by 2. So 8 by 3 plus 2 divided by 2, that gives me a 6. 14 by 6 ampere. 14 by 6 gives me a 7 by 3. So 7 by 3 amperes. I2 is x minus 4 by 2. So 8 by 3 minus 4 divided by 2. That gives me a minus 4 by 6 amperes. That is minus 2 by 3 amperes. And for I3 we have 8 by 3 minus 6 divided by 2. That gives me a minus 10 by 6 ampere. That is minus 5 by 3 ampere. So we got I1, I2 and I3. I1, since it came positive, so I1 flows in the left, but I2 and I3 came as negative. That means they flow in the reverse direction to what I have taken them. And you can see that minus 2 by 3 and minus 5 by 3, if you add them up, you get this quantity in reverse. So this is how you find for sums like this. You first need to find the potential of the unknown points, then you can proceed in the same way. In the next video, we'll be discussing a similar sum where you might have to take two different variables to solve a sum. So look ahead to that video. That's all we have for today. See you again in the next day. Like, comment and subscribe to our YouTube channel Mathophy for your daily dose of math and physics.